Hello everyone, I'm Bernie Dalisay from the College of Engineering and Technology. Allow me to present to you our humble study entitled Upgrading the Control Device System of the Ventilation Units in the College of Engineering and Technology building. A smart control device for a ventilation unit is self-sufficient, intelligent, and efficient in the way it consumes energy. It plays an important role in the lowering of energy consumption, keeping the airflow and climate fresh, and eradicating the need for manual control. It can customize a program to the ventilation system fitted to the occupant's requirements, air quality, and outdoor temperature readings from its many sensors. The smart ventilation system is integrated on the specific ventilation units and pays a higher price for the specific unit and application. Smart ventilation is a process to continually adjust the ventilation system in time and optionally by location to provide the desired benefits while minimizing energy consumption, utility bills, and other worst cases such as overheating and fire caused by unattended running ventilation units. The ventilation system is considered to be an important service in educational facilities. It makes the office and classrooms more comfortable, which would increase performance and productivity. The smart control device can be integrated into an existing ventilation unit to reduce the need for human intervention, increase security, and energy efficiency. The risk of ventilation units using without intelligent control device. In our issue, classrooms and offices, school and security personnel have reported and recorded unattended electric fans and air conditioning units working after school and work hours. Aside from its effect on the scale of electricity bills, it sometimes causes a fire that might damage the building structure and other essential things in the office. It is on this premise the researchers proposed the development and implementation of the smart control device system purposely for the systematic and automated operation of the existing air conditioning units and electric fans in the CET building. For the main objective of the study is to develop a smart control device for the existing ventilation units to minimize human intervention, easy to operate, and without any modifications to be made in the existing units. For the specific objectives, design and develop a compact control device that comprises the microcontroller, temperature sensor, passive infrared sensor, relay module, LCD, and a socket outlet. Conduct test performance regarding the operationality and functionality of the control device through the DHT11 and PIR sensors. And introduce the technology to the concerned unit by conducting an acceptability evaluation of the developed device. For the application and delimitation of the study, the control device will be applied in the CET building purposely to create an automated control in the operation of the ventilation units. This work is delimited to the development and utilization of the intelligent control device to control simultaneously the operation of existing air conditioning units and fans in the specific rooms and offices. And the project is also delimited to the acceptability evaluation regarding control device, reliability, durability, safety, and ease of operation. For the materials and methodology, the compact control device design is based on the components controlled and powered by the motion-activated and temperature sensors. The design for the prototype control device would consist microcontroller, temperature sensor, passive infrared sensor, relay module, LCD, and socket outlet. The developed control device has an inlet plug and outlet plug socket. The inlet plug is connected to a 220-volt socket of a building, while the outlet socket of the control device is where the ventilation units are to be plugged in. For the concept design, the 12-inch by 8 by 4 inches portable control device is made of sturdy yet light materials. The rectangular bottom compartment has a top glass covering. The framing of the glass cover has the same materials as that of the compartment. For the schematic circuit diagram of the study, the 12 by 8 by 4 inches portable control device comprises a microcontroller, PIR and DHT11 sensors, LCD, control relays, and other socket outlet. And in this slide, this is the developed unit. The control device system operation. For motion detection, the device will start once motion is detected. As long as there is motion detected, the device will continue running. If no movement is detected for 5 minutes, the device will automatically turn off. The control system operation based on temperature sensing. The temperature sensor is responsible for the turning on and off of the devices. If the temperature sensor reads more than 26 degrees C, the AC unit and the fan will power on. If the temperature reads between 20 degrees C to 26 degrees C, the fan will turn off, leaving the AC unit working. If the temperature reads less than 20 degrees C, the control device will turn off the unit, both the AC and the fan. The table above shows the experimental test conducted to determine the effectiveness of the installed sensor components in the developed smart control device for the ventilation units. The PIR sensor activates the control system 90%, considering there are moving objects at a distance of 1 meter to 7 meters away from the device. Correspondingly, the temperature and humidity sensor activates the control system certainly in the preset room temperature. The acceptability evaluation revealed that in terms of reliability, the employee respondents rated the control device 4.2, which is excellent, 3.8, also excellent for durability, 3.4, or very good for safety and ease of operation. For the conclusions of the study, the temperature sensor shows an average efficiency of 86.67%. Overall, the smart control device will be able to give more comfort to the room owner since it eliminates the use of manual control on the ventilation units. The outcome proved that using the developed model, operation of the ventilation system in the CET has improved. Further, this technology may help eliminate fire hazards due to unattended ventilation units running, thus reducing energy consumption. And lastly, for the recommendations, conduct further tests on the actual environment to increase the activation percentage of the unit. Include the safety switch in the control device for additional protection. Introduce the technology for commercial and residential use for a broader application. Secure for patent or utility model application for property. And that's all. Thank you for your time. God bless us all.